Hello guys. I'm a mechanical engineer working in the power plant. I was just a graduate engineer, so I like to learn a lot of things on my own. So I decided to practice while teaching something on the internet. So I decided to make few videos on the my engineering experience. I will try to teach uh, mechanical engineering aspects. What's some more instrument side, some more electrical side also. I'll try to teach it and learn it myself. So today we'll talk about the boiler control system. So specifically for CFBC boiler system. So there is many aspect of controlling in the boilers. So first of all, let's see how the boiler works. Then we'll talk about what are the control aspects, what to control, what are the protections in the boiler systems, and let's generally say overview. Let's take the overview of how boilers generally work. So this is a very basic, very overview type of diagram of representation of boiler. So there is multiple circuits, like this is a feed water circuit. The feed water is treated in the from the deaerator, and the boiler feed pump pumps it to at very high pressure, nearly around 150 kg, based on the steam pressure. So the BAP's pressure is dependent on the steam pressure also. So boiler feed pump pumps water into the boiler economizer. This is economizer section. The placement of the economizer, now it's very important. Placement of economizer in the part of boiler depends upon the boiling point. So boiling point depends on the pressure at which it is pumped. Suppose it is pumped at 148 kg pressure. The boiling point will be around 320 degrees centigrade, 330 or something. So the boiling point at which the saturated steam starts forming, and suppose what if we place the economizer in the here section, where suppose 900 degrees centigrade in here. So what will happen? The water will start evaporating on the pre-combustion section. There is no recovery from the downstream section. So that's a challenge. So economizer is placed after the superator section, so we can gain the maximum flue gas heat. For the economizer is basically a recovery of it. Name suggests from the flue gas. So excess heat recovery is also done using air preheaters. So let's continue from the where we left. We will start from the economizer itself. The feed water is preheated. Suppose water is coming at 200 degrees centigrade. Pressure is high, so water will not boil at this temperature. And suppose economizers adds around 50 degree of heat, the water leaves at 250 degrees centigrade. The 50 degree of enthalpy gain, it is significant. It creates a huge difference, and there is a lot of rule of thumb that like 6 degrees of flue gas will I don't know, I'll share it in later or maybe in a comment section. So water is preheated in the economizer, it goes to steam drum. Water goes to steam drum from economizer. It goes to steam drum, and then there is the drum is not fully filled, it's partially filled. So there is a steam and water separation goes here. In the natural recirculation boilers now, like water is come from downcomers, and then it is distributed along the furnace walls, divisional wall, side walls, front wall, rear wall, etc. Let me write it here: side wall, rear wall, front wall, etc. And it is divided here, and then water gets heated, the the heated water contains the mixture of steam and water, so it is lighter in the density. So recirculation basically works either through the force mode or either through natural. In the force mode, there is a pump at the downside, so it basically pumps. In natural now, there is a lot of density difference. Okay, so density difference is created by the heat given in the furnace. So when you heat is in the furnace walls, the water's density gets lighter because of the steam formation. The complete steam and water mixture becomes lighter than the full water, so it gets naturally upside, and then heavy density water gets downside, the mixture gets up, and that's how it recirculates. There is also a term related to recirculation ratio. So basically it's depend upon the design of the boilers, and it may contain like 7 to 8. So basically like the steam formation from the out of 100, it is 12 to 14% of water converted into steam, and else it's converted into water, else water gets recirculated back. So this is how it's steam formation. After that steam formation, the saturated steam goes to the superheating section, in which we gain heat in the downward section of the superheaters. See, the flue gas velocity at bottom part is not much high, but when it's get to the furnace top shaft now, the velocity gets very high, and the velocity, since there is an induced draft fan here and the stack which creates draft here, the velocity definitely increases on the downstream of the process. So this is a very high pressure, high temperature region. The steam which is coming here, let's suppose like it's say based on the boiling point of the say it's 320 degrees centigrade. Okay, now we require the steam at very high pressure, suppose very high pressure and high temperature. We require it very like 450 degrees centigrade. Okay, so we need to give extra excess heat to the saturated steam, and we'll heat it by using the superheaters. Also, suppose if we need to control this temperature, how will temperature control the temperature if of it? We'll add feed water to the multiple superheater intermediates. So like suppose there is three stage of superheaters, right? The feed water coming, saturated steam coming from the one will gets into the downstream of the first superheater, which is on the rightmost side, because there is a lesser temperature. So since less temperature of steam, less temperature of water, it's get a good start. Heat gets added and temperature gains. Suppose like we set the temperature of around like 360 degrees centigrade. So based on that, the feed water control flow valve will operate and add water to it. So we'll create more in detail. So there is a two stages of attemperation here. It is also called the attemperation. We'll talk about it later. See, this is steam temperature. We'll talk about later. So steam gets formed and it gets to the superheated output. Now the steam is formed. Let's talk about the flue gas. The flue gas generally is let's talk about air and fuel. Okay, the fuel is coal, and for startup we give NG, but not in the running condition. The coal is fed through the whatever like fuel feeder controls, like so we call it gravimetric feeders or reaction feeders. Okay, GMF or DCF. Fuel feed through that, and the control of the fuel is definitely made using the VFD. We can also control use other methods to control the flow. The fuel gets into the furnace. uh, the air, which is there may be multiple points like primary air fan, secondary air fan. The primary air fan is for on the CFBC. We use it for the fluidization purpose. It fluidizes the furnace, makes sure that it recirculates particles on the and provides a proper contact between the furnace walls and the combustion mixture. So proper heat transfer, making the proper heat transfer, we use fluidizing air, and it's different from the AFBC boilers. We'll talk about it later, not now. It will get we get away from the topic. So flue gas generated, it goes, catches velocity, transfer heat to the furnace wall, makes steam warmer or converts water into steam partially, not the full steam water is formed. It is for the natural circulation, as I mentioned. Based on the density difference, it recirculates and it goes to steam drum. Now the flue gas, which is having the coal, has the various properties, like there is a ash content in it, volatile matter, etc. So the ash contains, now there is two part. There is a bottom ash which gets settled into bottom, and the fly ash goes with the flue. So for that purpose, now we use impact separators here, which separates high density ash particles and separate it from that, and we separate ash from the fuel to get lower amount of solid particulate matter, SPM. Okay, so flue gas goes here, transferring heat to the superheaters, then economizers, then air preheaters. The air is preheated using the air preheaters, like suppose if we add the cold air into it, the efficiency of, we require larger amount of fuel to burn to get add enthalpy into the fresh air. So we use preheating waste heat of the flue gas to add enthalpy to attain the larger temperature heat gain in the fresh air using the waste heat of flue gas. So there is efficiency gain over here, and then the flue gas transferred to the electrostatic precipitator. We use corona effect to ionize the flue gas particles and discharge and neutralize it to less to control the amount of SPM in the flue gas. So for the environment norms now, we need to control the SPM, CO, SOx. SOx means the sulfur oxide compounds, NOx means nitrogen oxide compounds. All these are very regulated for the purpose of environment. They are very important to control. So we use electrostatic precipitator to control this SPM. And for the controlling CO, we need proper combustion. So this is also part of this video. So controlling, we need proper combustion, and for proper combustion we will use control system for it. And SOx, there is also a method to control SOx. And NOx. NOx is inherently created at the higher temperature range around natural nitrogen and oxygen, like N2 plus O2 creates NOx at higher temperature, like around 1500 degrees centigrade. But CFBC operates around 800 to 900 degrees centigrade. So PA pulverized fuel, they operate around higher temperatures, 1300 or plus maybe. CFBC operate around 850 degrees centigrade, 800 to 900. Okay, so NOx doesn't form here. SOx forms. So reducing the SOx, we use limestone for it. Limestone is basically calcium carbonate. You can also use magnesium carbonate. So this is basically overview of CFBC. Very vague introduction to the CFBC. We'll now move on to the control methods. So let's talk importance about the control methods. What if we didn't control it and run it naturally? Like fuel is going on, it's burning and it's creating steam. We won't get the desired output. For getting the perfect, reliable desired output, we need to give proper fuel ratio, proper air mixture, to properly control the environment norms, to properly ensure the reliability of the boiler parts. Pressure parts is very critical. Over pressurizing it will explode the damage the tubes, and suppose providing higher fuel and lesser air will create inefficient combustion, which will create explosive scenarios. Like suppose incomplete combustion is made, the CO explosion can be huge disastrous to boilers. They can explode the furnaces and can kill many people. So these are controlling the is very most important, and the current time it is very advanced. It is such that even if you can control in the remote place also, boiler is highly controllable, highly automated in current scenarios. So there are multiple sub control systems. There is a combustion control, there is a drum level control. Drum level is why the drum level. Suppose drum level on the higher side, the steam going will be the wet steam will hammer the superheater section. Suppose there is a water plus steam mixture, okay, and if the water and steam mixture is going in the superheater section, the water will start hammering and create steam hammer. If you have this dangerously sounding, it's very disaster. So prevent it, we use drum level control. Suppose the drum level is less, water has gone down very down, and the there is a heat in the furnace, and there is no water in the tube. The water tube will fill. There is a excess heat from the outside, but there is no cooling medium into it. They will starving from the cooling medium, and they will even rupture for the high rate from the high rate. So there is a drum level is very important. Control combustion is very important, because if the proper combustion is not made, they can create explosive scenarios. And very important for the efficiency also, steam temperature, as I see, like the downstream plants, process plants, we need proper steam control, steam temperature to uh, increase the efficiency of the increase the process requirements, sorry, increase the efficiency or reliability of the process requirements. Furnace draft, it is also very important. The fan discharge pressure, so it's also part of a protection. The pressure, the steam, yeah, that's also very important. Let's talk about some protections. So there is protection on the drum level. As I said, the lower drum level is also undesirable, higher drum level is not also desirable. So there is a lower limit also, there is upper limit also. So bed temperature, so in the coal, the ignition point of the coal is like around 500 degrees centigrade. Let's assume like 450 to 500. So coal can combust at greater than 500 degrees centigrade. So, and based on the, there is also lower side, okay, we cannot go over bed temperature to go beyond the coal combustion temperature. Lower limit. The higher limit is what? Suppose the bed temperature crosses the 1000 or 100 1011 or whatever degree centigrade, it will cross the design limit of the tubes. To protect the reliability of it, we use that part also. The fan discharge pressure. Suppose there is a clinker formed downward, for example. Okay, the fan, however, the fan will try to push, the it won't move, so the pressure of the discharge side of the fan will increase. So for protection of the fan, we use interlock for it to trip for prevention. Instrument here, nearly mostly the all the boilers have control systems are operated using control valves. So control valves are controlled using the pneumatic air. Suppose the pneumatic pressure of the air is lower than sufficient controllable pressure, then there will not be operated. So for protection of instrument, they will use lower side of, like, suppose minimum pressure at which control valve can be operated, we trip on that part. And safety side also, we take margin of that. The furnace pressure, suppose there is a lower pressure, the furnace will succumb and gets a very कुचुक टाइप, मतलब ऐसा हो जाएगा. और furnace on higher side, for improper combustion and over pressurizing it, it will explode, so we'll supply higher limit on that. Fan bearing temperature and fan vibration, that's reliability of fan. And for protecting integrity, suppose the fan is the oil temperature is very high, alignment is not proper, fan vibrations are coming very high, it's not a good practice to operate at that point, because suppose if it's crossing, if there's some issues of mass balance kind of thing, it will create loss of thousands of create loss of multiple crores. It will create equipment failure, which is not reliable, which is not a good, very bad practice for the industry. Now we'll talk about the individual part. This was the overview of it. We got into combustion control. Okay, so what is combustion control? I gave the overview of this thing slightly early. Just a second. So what are the objectives, like why we need to control the combustion? So first, importantly, it's for the environment norms, efficient utilization of fuel. Fuel is the most cost, almost very highly cost. See, fuel is costly, and efficient utilization of fuel, like for example, you are the daily you are operating, consuming 5000 tph of tons. Wait a minute, sorry. Of you consume 5000 tons of coal in a day. It is a realistic amount, many power plant consume that. So if you supposedly increase 1% of efficiency, how much it will be worth? 50 tons of coal. And what you know what the price of coal it is? Let's take around 10,000 rupees per ton. What will be 5 lakhs? You save 5 lakhs in a day just for the 1% efficiency. And if you operate around 1% efficiency for a month, how much you can make? You save 150 crore just for the 1% efficiency. You know what, 1% is very important. Every percent is very important. I just told you the importance of 1%. Okay, you remember that efficiency is the key to profits and sustainability. It is very important. If efficient utilization can create a lesser carbon footprint. We are deviating from the topic. So one of the most important part is efficient utilization of fuel. So that's why we use combustion. Stable steam production also. Suppose we use improper fuel feeding, then steam pressure will also like gets very unreliable, kind of that. It's not desirable. We need stable pressure. Suppose margins level, like if you operate boilers at around 110 kg pressure, and if some by suppose the rotary equipment gets stripped and boiler gets stripped, the network of the steam pressure gets dropped at 100 degrees centigrade, sorry, 100 kg pressure. Your downstream plants may get tripped. Your petrochemicals, petroleum, वगैरह plant gets affected. Suppose if you're using STG, there is a lot of performance effect on the STG also. So remember this thing: emissions. What was the second one? Efficient production of steam. Production, yet fuel consumption, and stable production of steam. Also, most important part, safety. Okay, safety why? If the proper combustion is not made, proper air fuel ratio is not provided, it's lesser than the threshold, then incomplete combustion is made. It will create hotspot on the particular areas where the improper combustion and create combustible gases which will explode like carbon monoxide. Okay, so these are the this is why we control the combustions. Now second part, what parameters we control. Parameters for the control of combustion. One you can guess is fuel flow, giving optimal fuel for optimal combustion. Okay, so we normally measure this in the energy. Okay, many use MMBTU, many use kilocalorie, sorry, mega kilocalorie, whatever. Okay, the fuel feed flow is controlled from this. The airflow, why these two things? If you have heard, there is air to fuel ratio. This is very important to control. There is in NG, natural gas, there is around 5 to 10% of excess air. In coal, there is 25%, 20 to 25% excess air. Means we are providing, suppose for combustion of 100 TPH of coal, there is very high amount. It's like 50 TPH of coal. Okay, we need, for example, 400 TPH of air. Air there is a 78% nitrogen, 20% O2 and around 1% argon. We consider this 20% is combustion. Okay, excess nitrogen will get, as it is, it is also primary factor for decreased boiler efficiency, because now heating this excess thing. So for example, there is a combustion requirement 400 pH of this thing, 50 pH of coal, and we also provide safety here 20%, 20 to 25. So like there is a 400 pH into 1.2 means 20 or 1.25. So what will get 480 pH or 580 pH? These things are calculated using the combustion logic. We'll dive very deep into the combustion logic later on. This is how why it is at like the airflow. The last element control loop is like dampers of the air. Let's see, this is control was like dampers. Okay, and fuel flow VFD, these are end element controls. So we use these things to control the fuel and air mixture. The second thing, what was that? Drum level, I think. Okay, wait a minute. Drum level. So I said that if it gets lower, if it's get higher, it will create wet steam, it will create dry out furnace wall. Also technical term is starving of water tubes. So it's like around 15 to 20% lower side, higher side is 75 to 80% higher. These are two limits to set because we need to control it's around 40 to 50% desired. To create proper separation of steam and water. Okay, let's move to next thing. What was that? Steam temperature. So how the steam temperature is controlled, like for example in drum the output steam is gone into the separator section 1. Okay, then from that SH2, the SH means separators, then SH3, this is final main steam. So for controlling the temperature now we can't control in the separator section. There is no, can't control it because the fuel has burned, the flue gas has arrived, and it will transfer heat from them to the saturated steam. Steam will gain the heat, it will increases enthalpy and increase the temperature. So for decreasing the temperature now we use we spray water here, here also, The amount of the water sprayed, feed water, which is also the same as going into the economizer. The amount of feed water stress can control this water temperature around 2 to 3%. 2 to 3% of steam production. Not very high. Okay, it's graduated the condensate temperature and final main steam temperature is arrived. The pressure part is not controlled. The boiler pressure depends upon the resistance in the downstream. For example, there is a steam header. Okay, and there is a steady state consumption of 400 dph. Okay, so for that we are generating 400 dph generation. The steam header pressure will be constant. For example, we are case 1. Okay, pressure is constant. Case 2, pressure increases. For example, we are generating 400 dph of steam. Suddenly the process plant trips, the demand gets decreased, or like demands get disturbed. There is a 380 dph of consumption. So excess 20 steam plus 20 dph generated will increase the pressure by a very good margin. It depends upon the volume of this header. Okay, now there is case 3. Okay, we are generating the 400 dph and suddenly they consume 500 dph of steam. The excess this at time t is equal to 0. Okay, they started consuming the plus 100 dph extra. You think that there is not generated, why it is consumed? There is a volume of air. Okay, header volume. So header volume will generally contain very good amount of steam, so it will drop the pressure by very high margin, and the pressure is very critical in the steam header part. In any chemical plant now, any chemical complex, the header pressure is very critical to the complex. This is power to trip all the complex, because steam is consumed by every plant, either very high pressure, low pressure steam consumed by all plants. Okay, so it's very good to. What about next? Let's keep it from till here. We'll create everything on the next video. So thank you. Okay, so this was my first video. I bought a one tab, so I teaching on here. I have no method to teach, so I started using the screen sharing and that part. So kindly forgive for improper explanation or my weak English. Thank you. I'll try to create videos on the piping calculations, hydraulic calculations, equipments working, energy performance, etc. I'll try to create everything which will be very helpful. I'm personally teaching for the sake of my purpose, for explaining or improving my communication skills. So this is not intended to gain any popularity on the YouTube. This is just for sake of my improvement of explaining things. Okay, so thank you very much, lot of you, thanks to you very bye, goodbye.